Welcome to AI Frontiers, mapping the latest in machine learning research. Today's episode offers a deep dive into 65 newly released machine learning papers, all posted on July 15, 2025, in the cs.LG category on the arXiv preprint server. We'll explore cutting-edge breakthroughs, reveal key research trends, and feature Palma et al.'s FlatVI as our paper of the day. Whether you're an engineer, student, or simply curious about AI, join us as we navigate the dynamic, vibrant landscape of modern machine learning. Consider this. Your smartphone's artificial intelligence now surpasses the power of the world's fastest supercomputers from just 20 years ago. Yet even with this extraordinary computational capacity, your phone's AI often struggles with basic ambiguities, such as distinguishing between a bank by the river and a financial institution. This very challenge is at the heart of 65 recent papers, each working to close these gaps and more. These studies are not just technical exercises. They directly impact fields like healthcare, privacy protection, fairness in automated decisions, and human creativity. On July 15, 2025, researchers worldwide unveiled their latest secrets, pushing the boundaries of what AI can achieve. Machine learning is the engine driving countless modern applications, from the apps on your phone, to advanced healthcare diagnostics, to the decision-making systems in self-driving cars. The 65 new cs.LG papers released today are collectively pushing the boundaries of learning systems and artificial intelligence. In this episode, we will unpack the core concepts of the field, identify the main themes shaping current research, and spotlight significant breakthroughs. Our purpose is to translate complex ideas into insights that are both accessible and actionable. Prepare to discover how today's research is shaping the future of AI and what it means for your world. What exactly is cs.LG? This is the arXiv preprint server category for computer science, machine learning, encompassing a vibrant and ever-evolving research community. Imagine this field as a sprawling city, with distinct neighborhoods dedicated to graph learning, robustness, fairness, and data privacy. Machine learning researchers act as inventive chefs. Rather than following a single recipe, they sample countless dishes and invent new recipes by detecting patterns and techniques. These models excel in complex, ambiguous situations where rigid rules fall short. Ultimately, this city of cs.LG is where research, innovation, and real-world impact constantly intersect. The first major research theme is representation learning and generative models. Representation learning aims to distill complex datasets into compact, meaningful forms, much like capturing the essence of a song using only a few descriptive words. Generative models go further, learning patterns well enough to create entirely new data. A notable example comes from Palma and colleagues, who introduced FlatVI, a method that sculpts the latent space, the hidden structure where learned patterns reside, so it reflects true biological relationships. This is akin to designing a secret garden where the paths mirror real-world biological distances. Such advances enable more effective data analysis and foster creativity in AI applications. Our second theme centers on robustness, uncertainty, and generalization. Robustness refers to a model's ability to handle noisy, novel, or shifting data. Uncertainty quantification, as explored by Fasel and others, allows artificial intelligence systems to recognize and admit when they are unsure, much like a GPS that recalculates routes when lost in a crowded city. Generalization remains a key challenge, ensuring that models can adapt to situations they have not seen before. Mastering these aspects is essential for developing safe and dependable AI systems that can be trusted in real-world, unpredictable environments. The third theme is graph learning and network analysis, a domain where data is structured as interconnected webs. Imagine a subway system where each station represents a data point and each line represents a relationship. Graph neural networks, or GNNs, are specialized for predicting and analyzing these complex connections. Song and colleagues, for instance, developed a graph-in-graph framework to model drug-target interactions, effectively mapping subway systems within subway systems. Advances in this area empower researchers to extract insights from social networks, molecular structures, and transportation grids. Let's highlight several key findings that exemplify scientific ingenuity across this research landscape. Song et al. Introduced Longevan Flow, a generative model for neural data inspired by physics, revealing hidden structures in brain activity. Kami and colleagues add privacy in federated learning using zero-knowledge proofs, allowing participants to validate model performance without exposing sensitive information. Boa et al. Developed Spark, a reinforcement learning framework encouraging language models to use diverse tools and reasoning strategies. Pence et al. Discovered that neural network layers can be decomposed into geometric rotors, enhancing both model interpretability and efficiency. Finally, Yang and collaborators presented AirLLM, which employs diffusion-based policies to optimize large language models for edge devices, reducing bandwidth requirements without sacrificing performance. Focusing on our paper of the day, Palma et al.'s FlatVIs, we first examine the motivation and the problem addressed. In single-cell biology, researchers require latent spaces that accurately reflect real biological cell transitions. However, traditional variational autoencoders, or VAEs, often produce latent spaces where straight lines do not correspond to true biological pathways. This disconnect undermines the trustworthiness of cell trajectory inferences. Palma and colleagues identified this issue and set out to align mathematical models more closely with biological reality, focusing particularly on the geometry of the latent space within VAEs. Palma et al.'s FlatVI addresses this challenge by introducing a penalty term during model training. This penalty discourages unrealistic interpolations within the latent space, enforcing a Euclidean geometry so that straight lines truly represent biological transitions. The approach was rigorously tested on both synthetic and real single-cell datasets, demonstrating superior alignment with known cell processes. The metaphor of tightening a spider's web is apt. The model balances mathematical rigor with biological plausibility, achieving a harmonious latent structure that is both accurate and meaningful. The impact of FlatVI is substantial. By producing trustworthy maps of cell transitions, FlatVI empowers biologists to conduct more reliable research in areas like developmental biology, cancer, and regenerative medicine. The journey to this breakthrough was marked by months of iterative experimentation as the research team sought the optimal regularization strategy. Regularization, a core machine learning technique, was key to their success. The process can be likened to carefully adjusting a web. Too loose and mathematical structure falters. Too tight, and biological relevance is lost. FlatVI finds the balance, enabling harmony between model geometry and biological truth. Looking to the future, the field of machine learning is charting new courses across a vast ocean of possibilities. One major direction involves integrating domain knowledge, so that AI systems possess not only accurate models, but also an internal compass grounded in physics, biology, or the social sciences. Federated learning is gaining momentum, enabling knowledge sharing while preserving individual privacy, much like sailors' secret-sharing navigational information. The importance of fairness and interpretability is also rising, with frameworks increasingly designed to ensure ethical and transparent decision-making. Finally, advances in uncertainty quantification will give rise to AI systems capable of explaining both their answers and their confidence levels. The ongoing journey seeks a balance between performance, privacy, and public trust. In conclusion, machine learning is both maturing and expanding its reach. The field is increasingly interdisciplinary, with a focus on fairness, privacy, and transparency. Landmark achievements by researchers like Palma, Song, Fasel, Bo, and others have set new benchmarks for the community. As listeners and practitioners, you are invited to remain curious, engage with emerging research, and critically examine the AI systems you encounter. Remember, the next chapter of artificial intelligence is being written now, and your participation helps shape the story. This episode was synthesized using advanced AI tools, including GPT 4.1 for content generation, DeepRAM for high-quality text-to-speech, and Google's image generation technologies. Every segment was reviewed by human experts to ensure accuracy and clarity. References for all cited works are provided, though some errors or omissions may persist. It is always advisable to consult original research papers for complete understanding. This podcast exemplifies the collaborative power of AI and human expertise in bringing you trustworthy research insights. Subscribe to AI Frontiers for weekly deep dives into the latest research in artificial intelligence and machine learning. Join our community of dedicated learners and innovators and help shape future episodes with your feedback and commentary. The AI Frontiers channel is your gateway to the evolving world of machine learning. Thank you for exploring the frontiers of AI with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. This video uses arXiv.org content under its API Terms of Use. AI Frontiers is not affiliated with or endorsed by arXiv.org.